So what you did, I'm just going to do a real quick recap here. A tangent line to a function at a point is a line that just touches the graph at that point, and it is somewhat parallel to the function at that point. And it's not quite exactly what we mean by parallel, but sort of. It's like going in the same direction. That's what a tangent line is. And I had a whole bunch of misconceptions. So I don't want to say it's a place where it touches and never crosses, because it can cross, like in that misconception 4. Then you had the tangent line problem, and we did talk about this one in Unit 1 just a little bit, but now we're going to make a beautiful connection. So we can start with what we call the secant line, where I asked you to pick 2 points, and how do you find the slope of the secant line? And then we move the point closer and closer and closer. And as we made that distance smaller and smaller, I asked you, what was that important concept from Unit 1 that would let that distance approach 0? What was that concept? The limit, okay? So here's the cool part. Up until calculus, we could only determine an average rate of change. When you introduce a limit and we let that distance, how close it is, approach 0, then we can actually determine the instantaneous rate of change. You didn't have the power to do that yet, and now you do. So we did average rate of change, which you've done for multiple years in math, and now you have what we call the instantaneous rate of change. So we're going to pick up in example 3. So above this, you have 2 possible formulas for instantaneous rate of change of a function at x equals a. So what the AP exam will do is they don't ever ask you to do it by hand like in example 3, but what they ask you to do is to actually identify that this is the instantaneous rate of change. Now, on the next quiz, I will likely ask you once to do it by hand, but then we will do a lot of identify. So if it asks me for the instantaneous rate of change of f of x at x equals -1, you may choose either limit. I think the one on the right is easier to work with. So I'm going to do the limit as x approaches -1 of f of x. Now a is this x value, okay? So that's minus f of -1 over x minus -1. So you're going to write the limit notation until you actually compute the limit. So f of x is x minus x squared. F of -1, if you need to, do it off to the side. That's -1 minus -1 squared. So that's -2 over x plus 1. All right, let's tidy that up, and we'll get the limit as x approaches -1 of -x squared plus x plus 2 over x plus 1. All right, if I try to directly substitute, I would be dividing by 0. So I need to try one of my limit techniques in order to evaluate this limit, in order to find the instantaneous rate of change. If you remember back to Algebra 2, one of my plans is this looks like a factoring type of limit. So before you factor, anytime that leading coefficient, the x squared, is negative, you're going to want to factor out the negative sign. So I'm going to factor out the negative and get x squared minus x minus 2 over x plus 1. All right, how does the numerator factor? X minus 2, x plus 1. And I'll tell you that there's usually a clue if you know, factoring is not your jam, then look at the denominator. That is going to be one of my factors, usually. So I'm going to cancel that and have the limit as x approaches negative 1 of negative x minus 2. So this is negative times the quantity negative 1 minus 2. So that's 3. So what have I actually found? I don't want us to get lost here in doing all this algebra. What we actually found is this is the instantaneous rate of change of f of x at x equals negative 1 is 3. What we just found is the instantaneous rate of change of f of x at x equals negative 1 is 3. That's what we found. So, an average rate of change is f of b minus f of a over b minus a. An instantaneous rate of change is allowing that distance between your 2 points to go to 0, so it creates, actually, the tangent line, okay? And it has a limit. That is the difference between average rate of change and instantaneous rate of change. All right, we're going to skip letter A in example 4. If you're really advanced, go ahead and try it, and I'll write out the answer in a little bit. But in the last period, it just was, for our first go-around, it was much, much too difficult of a problem to start with. So we're going to look at letter B, and I want you to look above at the instantaneous rate of change box. And I want you, this is the type of problem you would see on the AP exam. They're going to give you this and ask you to recognize what's the function and what is the x value is being evaluated at. This is the main part of what you're going to see on the AP exam. So try to tell me what is f of x and what is the a value here. So try that in letter B. All right, talk at your tables. What do you think f of x is, and what do you think the a value is? All right, Katya, what was f of x? I heard you say it. Yeah, what is it? Oh, I thought you said sine. F of x is sine x, right? F of x is just sine x. Because look, you're plugging, this one is the limit as x approaches a. So now we know that a is my pi over 2. This is f of x minus f of a over x minus a. So just f of x is sine x. Does that make sense? So this is the f of x, so that's sine x, minus f of pi over 2. What's the sine of pi over 2? It's 1. Yeah. And then this is x minus the pi over 2. Okay? There we go. And this does take a little bit of getting the hang of. Okay? It just takes a little bit of getting the hang of. And we'll look at one of the homework problems as well, if we have time. All right, so the instantaneous rate of change is also referred to as the slope of the tangent line, okay? So we can take this limit as x approaches c of f of x minus f of c over x minus c. If the limit exists, then it is the slope of the tangent line at the point where x equals c. So let's look at example 5. It says find the slope of the graph of f of x equals 2x minus 3 at x equals 1. Well, this is the slope of my tangent line is equal to the limit as x approaches 1 of f of x minus f of 1 over x minus 1. So let's tidy this up. F of x is 2x minus 3. And if you need to, do f of 1 off to the side. What's f of 1? Negative 1. Notice I have not evaluated the limit. I'm going to write the limit notation up until the point that I have evaluated. So that's 2x minus 3 plus 1 is minus 2. So the limit is 2. So my slope is 2. Now stop and think here a moment. We didn't need to do this, right, at all, because my equation was a line, y equals mx plus b. Don't I know that the slope is 2? Okay, so this was a captain obvious situation where I wanted to demonstrate with this limit definition how you find the slope. So lines, you know how to do that. What's going to be interesting is in the next example, in a parabola, there is not a constant slope. The slope changes at every single point. Let me say that again. Other curves, other than lines, have changing slopes, and you didn't know how to find those slopes until now, which is really, really cool. So let's try this now in example 6. We want to find the slope of the graph of a nonlinear function. So the slope is the limit as as x approaches 1 of f of x minus f of 1 over x minus 1. I'm going to pause a moment and give you a minute or two head start because I can go too speedy sometimes. So try and plug in everything you know, simplify, factor, cancel, whatever you need to determine the slope of the tangent line to the graph of f of x at x equals 1. While you're doing that, and to help me pause, is I'm going to give you this yellow paper. Cool. All right, f of x is x squared plus 1 minus, what's f of 1? 2. This is the limit as x approaches 1 of x squared minus 1 over x minus 1. Oh, that's going to factor beautifully into x plus 1, x minus 1. Now, I hope you understand why I'm continuing to go. If I plugged in, directly substitute x is 1, I'd be dividing by 0. So that's why I'm having to factor and simplify. So I cancel out the x plus 1's. So this is the limit as x approaches 1 of x plus 1. Plugging in 1 plus 1. Notice I don't need the limit notation there. So here's the cool part. If I just draw a parabola that's opening up, and I'm at x is 1, this tangent line has a slope of 2. Remember, this slope of the tangent line represents instantaneous rate of change. So as we move through, right now we're doing mechanics. Okay, we're just doing some mechanics. And then we're going to see these beautiful real-world applications of this as we move through the course. Now, what if I come in on the other side? We didn't do this one, but what do you notice about this purple line? What do you notice about its slope? It's negative. Okay, I don't know exactly what the value is, but I know it's negative. What about at the vertex? What would be the slope of that tangent line? 0, because it's horizontal there. Okay, I'm planting some seeds for where we're headed. All right, the limit equation we've been working with is so frequently used that it has a special notation. So if it's at a particular point, we call this f prime of z. And it is called the derivative. And we can also denote the derivative in general as f prime of x. So the slope of the tangent line, the instantaneous rate of change, is in fact our definition for a derivative. Okay? All right, last example. If f is a function for which the limit as x approaches negative 2 of f of x minus f of negative 2 over x plus 2 equals 0, then which of the following statements must be true? So this is a multiple choice question. So if you noticed in most of our notes, I was giving you multiple choice. In homework, I give you multiple choice. So let's kind of look at this and unpack it. So this limit, what does this limit represent? Yeah. It's the slope of the tangent line of f of x at x is negative 2. What else? Right above here. What is it? It's the derivative, okay? So this represents f prime of x equals 0 at x is negative 2. So when you look at these four choices, where can you see the answer now? What do you think? C. It is in fact C. The derivative exists. It's 0. It's okay. It's not undefined. It's 0. So here's what the writers of this question were doing. A lot of students would choose A because they see a fraction dividing by x plus 2. This is not the function. This is not f of x. This is the derivative of f of x. So that A is not true. The function being continuous at x is 2, this is at x is negative 2, so that's irrelevant. And then f is not defined at x is negative 2. We don't know that either. And actually what we're going to learn a little later is that in order for the derivative to exist, the function has to be defined there. Okay? All right, so that wraps up our notes. So you have the rest of our time. You ended up with about 15 extra minutes.